Hello guys and welcome to Tech Foundation Africa. I am Professor and I'm very excited to share with you today. This is the first video tutorial in our programming with modern C++ tutorial series, and more will follow. In this tutorial, I will talk about some fundamental concepts of programming and the modern C++ programming language. This is the outline of the tutorial. I'm going to speak about programming languages, text editors and IDEs, the modern C++ language, and finally, what you are all looking forward to, we'll get our hands dirty with some basic C++ application. What is programming? Now, before getting into the computer environment, what do we mean by programming in our daily lives? Let's take for example, when you go to church, there is an order in which the service is performed. Now, that order is a program that is executed by the church. In computing, however, or in computer science, programming is a way of presenting ideas in code. We can say that programming is the process of creating a set of instructions that the computer has to perform, okay? And that makes programming a tool for writing computations. So basically, when we talk of programming, to the computer scientist, it's a tool that he uses to write computer solutions or to write computations. All right. Now, there are some myths about programming. When we talk of a myth, it's a widely held but false belief or an idea. Now, let's look at some of the most common myths about programming. The first myth I want to talk about is that the fact that you can program or you are a programmer doesn't make you a computer scientist. The field of computer science is so broad that programming is just a tool. It's just an aspect of what a computer scientist does, okay? And I wouldn't be surprised to see a computer scientist who doesn't even write code, because these people are the people who are concerned about the efficiency of programming languages. They are the people designing the algorithms that we are using on our daily basis. Now, most often, the people we call programmers, they are the people who make use of these tools and knowledge that the computer scientist has come up with to create application and stuff. So please, the fact that you are a programmer does not make you a scientist. Being a computer scientist is way bigger than just writing pieces of computer codes. Another thing is that people say programming is easier in one language than another. So one thing that you hear often is that it is easy to program in Python, or programming is easy in Python. Let me put it like this: programming is easy in Python than in C++. Now, what people usually forget or don't know is that programming is independent of the language used, okay? Programming in itself is an art. It's a standalone thing. Your ability to convert problems into computer solutions, your ability to come up with algorithms to solve problems. Now, this particular activity is independent of the language used, okay? So to say that programming is easier in one language than another, it doesn't make sense. Now, let's look at this analogy. Assuming I want to describe myself. Now, I speak 3 languages, so technically I can describe myself in 3 languages. So let's say I want to say something like, my name is Eric Obin, I am 10 years old. Now, that is English. If I come to my native language, which is Ghanaian language or Twi, I would say that Midin di Obin, Medin Fiedu. Now, to say this same thing in French, I would say something like, and the French guys, please don't pick me on. My French is rusty. I would say something like, Je m'appelle Eric Obin, j'ai 10 ans. Okay, good. Now, you realize that what mattered here was my ability to describe myself, and that is the programming aspect. But the language of choice through which I express that idea is actually a choice that I make. So if I ask you to describe me and you don't know me, it doesn't matter how fluent you are in French, or how fluent you are in English, or how fluent you are in Ghanaian language, you cannot describe me. Is that okay? So when such a thing happens, would you say that it is difficult to describe Eric Cobain in French than in English, or what? No. You see, usually when people complain about programming in a particular language, what I have realized is it is not the language that is a problem to them, because come on, what does it take to learn a computer language? It's just just memorization and trying to understand how certain things are done. Okay, but then usually people's problem are with their ability to think computationally, their ability to come up with computer solutions, come up with algorithms to write or to solve the problem they have. Is that okay? And because of that, so trust me, if you have problem programming in Python, look, we can actually go and create the most basic and simplest form of programming language for you. You would still have problem programming, because your problem is not with the language but with the art of programming itself. Now, that is not to say that some programming languages have a very friendly syntax. Yes, if you look at Python, for instance, it originally was created to teach kids how to program, so it has that kind of English-like syntax, which makes it easy to learn. Is that okay? Now just take a Russian, okay, who is programming in Python. Do you think he's going to find Python to be that easy? Because you are probably biased with English, so when you're able to remember the syntax, but somebody like a Russian who is not English native, now learning English becomes another thing. Is that okay? So yes, there are some programming languages that are very friendly than others. Some are symbolic, some are more English-like. Yes, that fact is there. But then programming in itself is independent of a programming language. Now, the next thing I want to talk about is the fact that people think women cannot write code. Hello, please. There are a lot of women doing awesome stuff in the IT industry. My favorite is Lady Ada of Adafruit. That lady is just so awesome and so amazing. So please, just if you have that mentality, just wipe it. Okay, just wipe it. Now, another one is that all programmers are nerds and lonely people. Well, the media, Hollywood, for instance, may have not portrayed programmers, as they are. Yes, and there are a few people who are that kind of reserved and would like to dissociate themselves from people and be writing code. Yeah, in natural sense, we have people like that. But you see, modern programming goes beyond writing code, and not just modern programming. From the days of old, writing codes is not programming is not just about writing codes. Okay, writing codes is just an aspect of programming. Programming involves a lot of mental effort, a lot of mental activity, your ability to understand the problem and come up with a solution. Is that okay? So the coding aspect just comes in as should I say, the execution of your idea. Is that okay? And right now, if you're a programmer and you are managing your own startup, then you do more than just coding. You have to be the one meeting with the clients, trying to brainstorm ideas and come up with what the client will love and all those kind of stuff. Okay. And one thing I've known about programmers of late is that they like to party after party. Party after party. All right. So these are a few myths that I wanted to debunk. Now, what are programming languages? When we talk of programming languages, what are they? Now, in our previous church analogy, in order for the church to execute its program successfully, the facilitator has to communicate the activities to the audience. Well, this is done through a language, and the most important thing here is that the facilitator and the audience must understand the language used. Now, do you remember the story of the Tower of Babel? You see, human beings have different languages, and this differ from culture to culture, and from place to place, from continent to continent, country to country, and even within the same country, within the same town, there can be different languages. Okay, so take Ghana for instance. In Ghana, among the accounts, we have the Ashantis, and we have the Fantis. Okay, with slightly different language. Now, each of these languages has its own set of rules, syntax, and semantics. Syntax is the right way of writing things, like the grammar. Is that okay? And semantics has to do with the meaning of the things. Now, the way sentences are constructed in French is different from the way they are constructed in English, and so on and so forth. However, one idea can be expressed in all languages. Some languages can express an idea better and precisely than others due to the level of vocabulary the language has. So, when we talk of programming languages, language in general is a structured system for communication. Okay, so that makes a programming language a formal language which comprises of a set of instructions that produces various kinds of output. So the question is, when we speak programming language, or when we talk about programming languages, what are the parties? So in this case, the parties, on the human side is the programmer, on the device side is the computer. Is that okay? So the same way the facilitator in the church has to be in agreement with the audience, the computer programmer and the computer should agree on the things they want from each other. Is that okay? All right. Now, programming languages are used to implement algorithms. I'll talk about algorithms in a future video. And currently there are over hundreds, if not thousands, of programming languages out there. Okay, some of them are obsolete and outdated, and there are still new ones coming. You see, the evolution of programming languages, the history of programming languages is an interesting one. So somebody comes up with one language, another person sees a fault or a low side of it and fix it and come up with another, or enhances a feature, makes it better for something else. Okay, so these are some of the things that have driven the creation or invention of programming languages. Now, there are also some myths about programming languages, and I want us to look at just one of them. You hear people say something like one language is better than another. So for example, you hear people say, people of the view that Python is better than C++. Okay, but this is not true. This is not true. The truth is, if you ask a system designer, somebody whose work is to design device drivers, design firmware for systems, who is used to programming in C++, he's going to have a different view about C++ and Python. Now, if you talk to somebody who is a back-end programmer, writing server-side applications for websites and all those kind of stuff, they are also going to have a different view about Python and C++. Okay, so in a nutshell, there is no one language is not better than another. Holistically, that is not true. But contextually, yes, a language may be better than another in doing something. Is that okay? Because like I said, if you look at the history of programming languages, languages evolved because somebody wanted to do something and the language at that moment couldn't help him do it better, so he comes up with a more an interesting way of doing that thing well. So all languages have their strengths, all languages have their weaknesses. So that does not mean, or that does not make one language better than another. But then if we limit the scope, then yes, we can say that in certain respect or in certain aspects of programming or computing, Python has much strength than C++, or C++ is better or is preferred than Python. Now the next one is a super programming language. Actually, there is no universal programming language. Every programming language does something well at the expense of another. So you won't get a holy grail, a programming language that tops all. No, there is nothing like that. Okay, there is nothing like that. And if you look at, I think if you look at the way programming languages are ranked, it's kind of seasonal. Okay, kind of seasonal. Recently, you realize that a lot of web applications focus is much more on web applications, on artificial intelligence, and there are a lot of libraries created created for artificial intelligence in Python. So it makes a lot of people move in that direction. Okay, so the ranking is kind of seasonal. It's not something from. For some time ago, Java used to be at the top or the hot cake, but you realize that this season, yes, Java is still part of the top 5, but then it's not the first on the list. Okay, all right. Computer programming languages can be classified based on different criteria. A common criterion is classification based on how close the language is to the hardware. So let's look at it. With respect to closeness to hardware, then we can group computer languages as low-level languages and high-level languages. Now, some people do talk about mid-level languages, but I don't see the essence of that, so I'm not going to talk about that. So, when we say a programming language is low, it means that it is more closer to the hardware, which is the computer's processor. Is that okay? So, talk about machine language, talk about assembly language, these are very close. Okay, these are very close. In fact, assembly language is just a step away from the hardware. But then if you talk about high level languages, we are talking about the likes of C++, Java, C, Python, and the likes. Okay, now you realize that in these languages we code almost like in English. They contain their syntax is made up of natural languages. Okay, they operate on a very higher level of what we call abstraction. Okay, so they are far before you can get a C++ program, for instance, to run. It has to be compiled and converted into a machine language. You can't run the C++ or Python or Java application directly on the computer without compiling or converting it into machine language. So all languages in this category are said to be high-level programming languages. Now, we can also categorize or group programming languages according to their process of conversion. That is the process in which their source code is converted into machine code. Is that okay? Now, in this respect, we have interpreted languages. Talk about Python, talk about PHP, okay, talk about MATLAB. These are examples of interpreted languages. And we also have compiled languages. Now, what is the difference? Let's see. For a compiled language, after you create your program, which we call the source code, a program called compiler has to take the source code, go through it, make sure everything is syntactically correct. Then when it passes, it will convert the source code, which is written in a high level language, into machine code. Remember, the only code the computer can understand and execute is machine code. Is that okay? So by doing that, the compiler will convert this to machine code. So the output is what we call the machine code or object code. An interpreter doesn't work that way. for an interpreter, when you pass the source code to it, it picks it line by line. Okay, so it picks one line, convert it to machine code and execute, picks another, do the same thing. Is that okay? Now, each of these types has its own strength and weakness. For instance, if you take interpreted languages, they make developments faster because you don't have to wait for the entire program to compile anytime you make changes to your code base. But for compiled languages, anytime you change even a letter, you have to wait until the program compiles to generate the executable. However, you see, this is also the strength. The weakness of the interpreted language is the strength of the compiled, in that, let me create this analogy. Let's say that we have two rockets about to be launched into space. Now, rocket A is programmed with Python, which is an interpreted language, for instance. Rocket B is programmed with a compiled language like C++. Good. Unfortunately, there is a bug which is triggered after the rocket makes its maneuver in space, in our atmosphere. Is that okay? Now, if this is a syntax error, C++ compilers will catch them through an error, and they will force you to fix that error before generating the output machine code for the rocket to run. So that means that the C++ rocket will fly to space to its destination without any problem. Now, the interpreted the rocket A, which is programmed with interpreted language like Python, would not do the compilation. So right from start, it is going to launch the rocket airborne, and when the rocket is about to maneuver and this error triggers, what will happen is the code execution will stop. So now tell me, what do you think will happen at that moment? Okay, so each of these has its own strength and weakness. The choice is about you, the programmer, what you want to do and which of them serves you best. You see, programming languages are tools. Just use them. Don't get attached to a particular one. Just learn them and know which of them to use for the right job. A dormer machine, a scissors, a razor blade, a machete, these are all cutting tools. But you see, if I ask you to cut your fingernails, you will not take a dormer machine. Well, you can try that sometimes. Then we also have assembly language. Assembly language is actually a low-level programming language designed for specific type of processors. So what this means is that every processor comes or has its own assembly language. That means that if you are an assembly language programmer, you would have to be learning different codes for different processors, and that's quite boring. Okay. Now, there is a program called assembler that converts assembly language into machine code. Now, assembly language uses what we call mnemonics, which are abbreviations that represent operations to be performed. Now, finally, on computer programming languages, I want to talk about machine language. Now, machine language is the only language a computer understands. No matter what programming language you like to program in, everything you do in that high-level language has to be converted into machine language before the computer can execute it. Now, machine language consists of only binaries, zeros and ones, or sometimes we can have representations in hexadecimal or base 16. Is that okay? And every programming language, like I said, source code has to be converted into machine language. So let's look at a typical example of hello world in machine language. So you see this pattern of bytes or 8 bits. Yes, this is a typical example of machine language code that will display hello world. So assuming you are to code an entire operating system this way, that would be fun. All right. Now, to create a program for the computer to execute, we need text editors. Now, there are two main ways of doing this. You can use ordinary text editors like Notepad, or you can use a more complex versions called IDEs. A text editor is a program that creates text files. So talk of Notepad on Windows platform, talk of Notepad++, talk of Vim, Nano, Gedit, Emacs. All these are examples of text editors. They only create text files without any formatting or that kind of thing. Now, when we talk of IDEs, or Integrated Development Environment, these are programs that provide a more comprehensive and robust tools for software development. Now, typical example is what we'll be using in this training, which is Dev C++. We also have the likes of Microsoft Visual Studio, NetBeans, PyCharm, CLion, and the rest. So again, these are tools. Some are free, some are proprietary, so you have to pay for them. But the thing is, get what works best for you and use it. It's just that. Okay, now, like every field of study, there are always some terminologies. Your success in the field is partly dependent on your ability to understand these terminologies. So let's look at some terminologies associated with programming. You've heard of a program. A program is nothing but a set of instructions that a computer executes. The process of writing program, or the process of writing programs, is what we call programming. Now, the step-by-step process that a program follows is called an algorithm. So in cooking, you see, when a lady is cooking, or when someone is cooking, a chef is cooking, he follows what we call a recipe. So recipe is analogous to algorithms in programming. Okay, a program written in a high-level language is usually called a source code, and we've talked about high-level languages, the likes of C++ and Java. Now, source codes are contained in source files. In computer terms, when we talk of a file, it's just a sequence of bytes on a storage device. So the storage device here will mean things like the hard drive, the pen drives, and the likes. Okay, now files on a computer system are organized in folders or directories. Every file has three main parts. We have the path. Now the path talks about, or shows us where on the file system that file resides, and every file has a name. That is what we use to identify it. And the last part, which is the extension, which is just a suffix that is attached, the suffix of the name, which is limited by a period. Okay, so the extension, what it does is that it tells the operating system how to handle the file. It helps the operating system to associate the right programs to a file. So if you go into your file system right now, let's say if you create a C++ file on your desktop, you realize that your default text editor is assigned to it. So that file gets the icon of your default text editor. The operating system is able to do these things because of the extensions that we supply. Now, examples of extensions, we have .mp4 for video files format, we have .mp3 for audio, .doxc for Microsoft Word, and so on and so forth. Now, C++ source files have the extension .cpp, .h for header files, .cc, etc. So source files are ordinary text files. Source files are written in text editor. So if you take a folder, so this is a folder. Remember, I said files are organized into folders. So this is a folder which has a collection of files. This is a typical example of a C++ source code or source file, and this is the output. So you can see with the source file we have the extension .cpp, and with the output we have the extension .exe. And you realize that the icon of the .cpp is different from that of the .exe. So the operating system is able to do all this because of the extensions. This training is about programming with modern C++ programming language. So what is modern C++ programming language? How does it differ from the C++ that we know? Okay, so let's look at that. Originally, C++ was designed by a Danish computer scientist called Bjørn Stroustrup in 1980. Now, it is actually one of the oldest programming languages that is still in use. Okay, and then it has actually maintained its position as part of the top 5 popularly used programming languages in the world. Any kind of program can be written in C++. Talk about games, talk about databases, operating systems, device drivers, server applications, any programming, mobile applications, embedded systems, firmwares, and all those things. You can implement all these in C++ programming languages. And actually, major applications like operating systems, office suites, browsers, all these things, if they are not fully implemented in C++, they are at least partly implemented in C++. So I can say that there is a piece of C++ in everything. Okay, because if you take Java for instance, Java Virtual Machine, the JVM itself is implemented in C++. Other languages themselves, okay, the languages, their interpreters are actually even implemented in C++. So you can say that C and C++ are language of languages. C++ is best suited for applications when performance and resource constraints matters. Typical example, when you are programming in the embedded system world where memory is a constraint. Okay, if you take a microcontroller like Atmega 328, you have only 2 kilobytes memory. By the time the Python interpreter is even downloaded, that memory will be used up. Now, programs written in C++ are many times faster than those written on other popular languages. Yes, and that is true. You see, let's compare C++ and Java for instance. Java's main strength or popularity lies in its ability to achieve architecture neutrality. Now, architecture neutrality here just means that once you write a piece of Java application, you can run it on any platform, Mac OS, Linux, Windows, without having to change anything. Is that okay? Unlike C++, where if you compile a C++ program on a Windows platform, for instance, it will only work for Windows platform. You can't run that output or execute that program on Mac OS. Now, take note, C++ source codes themselves are portable, okay? But when you compile them, their output are not portable, okay? Now, Java achieves this by introducing a middleware called the Java Virtual Machine. Is that okay? So when you create a Java application and you compile it, it generates what we call bytecodes. Now, these bytecodes are like machine language for the Java Virtual Machine. So before you can actually execute that bytecode, you need a Java Virtual Machine. And since all the operating systems comes with Java Virtual Machine installed, it means that you can run your Java application on almost every application. But then let's see, that means that there is a latency or a delay, okay, that from the time that the Java Virtual Machine will process the bytecode into the native machine code. You are going to have a bit of delay, okay? So that makes C++ programs much faster than Java. C++ programs are also effective than most other languages in developing cross-platform applications, okay? And like I said, C++ is almost becoming the de facto program when it comes to embedded system applications, where we have a lot of resource constraint in terms of memory and processing speed. So what then is modern C++? Now, after its initial development and standardization in the 1980s, C++ actually evolved slowly, and this has actually played a role in its depopularity, if there is a word like that. Is that okay? And this continued until the International Organization for Standardization, aka ISO, released a new version of the standard that formally defines the C++ programming language. Now, the This edition of the C++ language is what we commonly refer to as C++ 11, and it has actually brought C++ to par with the modern languages like Python, Java, and the likes. Okay, it has almost modernized the C++ programming language completely, and so you can actually say that C++ 11 is a completely new programming language. Now, programming using the features of C++ 11 and beyond is what we refer to as modern C++. So anytime I talk about modern C++ or you hear modern C++ anywhere, then it means that we are talking about programming using any edition starting from C++ 11. Okay, so modern C++ is just about the modern ways of programming, the consensus of what constitute good programming style. The current versions of C++, we have C++ 11, 14, and 17. Now in this tutorial, we will be using C++ 17 for everything. All right, we've spoken enough. I can't leave you empty-handed. So let's end this video in a grand style. Let's write our first Hello World application, and to do this we will use the C++ IDE. I have recorded a video on this channel that shows you how to install and set up the C++ IDE for modern programming with C++. And in this training we'll be using the modern C++ standard 17, like I said. So let's get our hands dirty. All right, so first of all, I'm going to launch my dev C++ IDE. Okay, so that is how it looks like. Very ugly but beautiful on the inside. Now to create a new program, you can use the shortcut Ctrl+N, or you can go to File and click New and just Source File. Okay, all right, now let's save it. Ctrl+S will do the magic. Okay, we haven't entered anything, so it's preventing us from saving it. So let's enter some codes. You don't have to understand the codes I'm about to write, just look at them. Okay, I don't like the font size, so let me go in there and increase it. Font, let me set it to 18. Okay, okay, so now let's save this as hello, just hello. Okay, so this is a basic C++ program, and all it's going to do is to print hello world to the screen. All right, so let's compile and run it. Hit this button, and voila, you can see over here, hello world, C++ is fun. All right, so that is just that. We've written our first hello world, or our first modern our first C++ application. All right guys, this is the end of this tutorial. I want to say a very big thank you to our sponsors and partners. They are the reason we are able to make this video available for free. Saytech is our cherished sponsor, and they design smart machines for African agricultural industry. Okay, so I know currently they have threshers for threshing maize and other cereals. So if you have a farm and you have a problem threshing your cereals, please just give them a call. They will come and they come and talk business with you. If we also have Tech Technologies, they are dealers, they retail in electronic components. So the guys in Kumasi and Accra, wherever you are, they actually do ordering. They can send you your orders. You can order and they will send it to you. If you need components for your electronics projects, sensors and all those things, please contact them. Then we have electronics. In fact, the tutorial is brought to you kind courtesy electronics. Okay, I am Professor and I am the CEO of Electronics. Then finally, we have Teskin Enterprises, the #1 electronics retail shop in Achemfo Market, Kumasi. Okay, so anytime you guys come around and you need some components, contact these people and they will sort you out. Get your component from them, buy from them, so that they will also be motivated to sponsor us to bring you more free video tutorials. We want to make these trainings better and fun. Your support will help us to do more free tutorials. Now, if you can donate any amount of money to support our cause, please just Momo it to the number on your screen. Okay, if for some reason you can't Momo, you can email us on techfoundationafrica@gmail.com and let's talk about some business. All right, thank you for watching. Don't forget to leave a nice comment, like and subscribe to this channel. I am Professor and this is Tech Foundation Africa.